The star system Alpha Centauri is situated in the Centaurus constellation in the southern skies, comprising 3 stars, namely Rigil Kentaurus, A Centauri A, Ptolemy, A Centauri B, and Proxima Centauri, A Centauri C. It holds significance in astronomical observations. Of the 3, Proxima Centauri, standing at a distance of 4.2465 light-years from the Sun, claims the title of the nearest star in proximity to our solar system. On the other hand, Alpha Centauri A and B, marked as the closest stars visible without aid, put on a celestial show. Rigil Kentaurus and Ptolemy, resembling our Sun in their characteristics as Class G and K stars, create a captivating binary star system referred to as A Centauri AAB. These dual stars, with an apparent magnitude of 0.27, appear as a single luminous entity to the unaided eye, making them a dazzling sight in the night sky. Orbiting around a common center with a duration of 79 years, these stellar companions travel in an elliptical path, leading to varying distances between them. Taking a closer look, Rigil Kentaurus outshines Ptolemy in both mass and luminosity, boasting 1.1 times the mass of the Sun and 1.5 times its luminosity. Conversely, Ptolemy shines brighter in its uniqueness, with a smaller stature and cooler demeanor, casting less light with 0.9 times the Sun's mass and under half its luminosity. Proxima Centauri, a faint red dwarf falling under the M classification, remains inconspicuous to the naked eye, but rules the realm of proximity to our solar system. Approximately 13,000 astronomical units away from a Centauri AB, Proxima Centauri claims a close proximity, rivaling its neighbors in nearness to the Sun. With 2 confirmed planets, Proxima B and Proxima D, orbiting its dominion, this diminutive star showcases its planetary entourage. While Proxima B lingers in the habitable zone, its capacity for habitability may be uncertain, in stark contrast to the proximity of Proxima D, a sub-Earth planet that audaciously nears its host star. Adding to the cosmic drama, Proxima C, a debated mini-Neptune, positions itself at a distance of 1.5 astronomical units. On a speculative note, Rigil Kentaurus hints at the potential presence of a Saturn-like planet within its habitable zone, further deepening the allure of this stellar trio in the Alpha Centauri system. In a stark contrast, Ptolemy appears devoid of any planetary companions, marking a celestial solitude amidst an ensemble of cosmic wonders. Alpha Centauri, given the designation by J. Bayer in 1603, is located in the constellation Centaurus, named after the mythical creature part human and part horse, which Greek mythology claims Heracles inadvertently injured, leading to its placement in the sky after its demise. The right front hoof of the centaur is depicted by Alpha Centauri. Referred to as Rigil Kentaurus, a derivation from the Arabic translation Rajul al-Qantors, Rigil al-Kinturus, signifying the foot of the centaur, this name finds its roots in the Arabic transliteration of the Greek Kenavros, Kentaurus. Often shortened to Rigil Kent or Rigil, the latter name is more commonly associated with Rigel v. Orionis. In European sources, an alternate name Ptolemon is a rough equivalent of the Arabic of Lyman az-Zalaman, meaning the 2 male ostriches, a term originally applied by Zakaria al-Qazwini to the stars Lambda and Musagatari. The name Ptolemon was introduced by Jacob Golius in 1669 from Al-Farghani's compendium. Golius Latinized the Arabic name of Dhulman al-Zulman as Toliman, being the primary star of an asterism. The discovery of a Centauri C in 1915 by Robert T. A. Innes led to the proposition of naming it Proxima Centaurus, which originates from Latin denoting the nearest star of Centaurus. Eventually, Proxima Centauri became the prevailing name and is now officially recognized by the International Astronomical Union, AU. In 2016, the IAU Working Group on Star Names made the decision to assign proper names to individual stellar components rather than whole systems. Consequently, they endorsed the name Rigil Kentaurus for a Centauri A and Proxima Centauri for A Centauri C. Finally, on August 10, 2018, the IAU designated the name Ptolemy for A Centauri B. Alongside these designations, other names have also been used historically. During the 19th century, the amateur popularist E. H. Burritt referred to Alpha Centauri as Bungala, a term with uncertain origins possibly linked to the Greek letter beta, Furke, and Latin ungula, hoof. In Chinese astronomy, Alpha Centauri is part of an asterism called Nanmen Nanmen, or Southern Gate, alongside Epsilon Centauri. The indigenous Burung people of northwestern Victoria, in Australia, have their own names for Alpha Centauri and Beta Centauri, naming them Burmburmgull or Bram Bram Bult, portraying them as two brothers renowned for their valor and destructiveness in their legends. Alpha Centauri AB is the brightest star in the southern constellation of Centaurus. Despite appearing as a single star to the naked eye, it is actually a binary star system. The pair's apparent angular separation ranges from 2 to 22 arcseconds, making them distinguishable in binoculars or small telescopes. Over the years, astronomers have carefully monitored Proxima Centauri for fluctuations in brightness using a variety of telescopes, with notable flares recorded in August 2015 when the star became substantially brighter for a brief period. Journals from the 2nd century, including Ptolemy's Almagest, mention Alpha Centauri and provide its celestial coordinates, showcasing the historical significance of this stellar system in human astronomical understanding. Alpha Centauri is possibly located inside the G cloud of the local bubble, and one of the closest systems known to it is the binary brown dwarf system Lumen 16, situated 3.6 light-years, 1.1 parsecs, away. Various historical distance estimates have been documented for Alpha Centauri AB throughout the years by different sources. From H. Henderson's observation in 1839 to the Recon's Top 100 report in 2012, the parallax, distance in parsecs, light-years, and petameters have been meticulously recorded. Proper motion of all components of Alpha Centauri has been noted against the backdrop of the sky, leading to slow but noticeable changes in their apparent positions over centuries. The calculated proper motion of the center of mass for Alpha Centauri AB indicates movement towards the west and north, with an overall motion towards a direction slightly north of west. Spectroscopy has allowed the determination of the mean radial velocity to be approximately 22.4 kilometers towards the solar system, resulting in a speed close to the peak in the distribution of speeds of nearby stars. Predictions suggest that Alpha Centauri will experience significant position shifts in the sky and a gradual increase in brightness in the coming millennia. An intriguing event foreseen is a stellar conjunction with Beta Centauri in about 6,200 CE, forming a dazzling optical double star in the southern sky. By around 26,700 CE, Alpha Centauri is expected to reach perihelion, shining brightly at a maximum apparent magnitude, but not surpassing the brilliance of Sirius, which will remain the brightest star visible from Earth for the next 210,000 years. Alpha Centauri is a triple star system with two main stars, A and B, forming a binary component together. The AB, or AX-B designation, marks the mass center of the main binary system relative to companion stars in a multiple star system. The ABC designation deals with Proxima Centauri's position in relation to the central binary, indicating the distance between the center of mass and the outlying companion. Owing to the proximity between Proxima, C, and either of Alpha Centauri A or B, some treat the AB binary system as a singular gravitational entity. The orbital properties of Alpha Centauri revolve around the dynamic interplay between the two main stars, with an orbital period of 79.762 years and a moderately eccentric orbit, with a periastron of 11.2 AU and an apastron of 35.6 AU. Alpha Centauri A, also known as Rigil Kentaurus, is a G2-type main-sequence star slightly more massive than the Sun. Its counterpart, Alpha Centauri B, or Ptolemy, is a K1-type main-sequence star with around 90% of the Sun's mass. Alpha Centauri C, better known as Proxima Centauri, is a small red dwarf positioned about 13,000 AU from the AB pair. Proxima Centauri has an eccentric orbit, with periastron at about 4,100 AU and apastron at 12,300 AU. The ages of these stars are estimated to be between 4.4 to 6.52 billion years based on various analyses. The Alpha Centauri system has two confirmed planets around Proxima Centauri, with additional hypothetical planets possibly orbiting Alpha Centauri A or B independently. Recent advancements in observational techniques, such as radial velocity measurements, have enhanced the search for exoplanets in this stellar system. Theoretical studies suggest the potential for terrestrial planets in the habitable zones around Alpha Centauri A and B. Evidence indicates a possible circumstellar disk in the system, indicating interactions with the surroundings, exchanging material with the far regions of the solar system. The sky viewed from a Centauri AB would be reminiscent of Earth's sky, with the notable absence of Centaurus's brightest star, a Centauri AB itself. The Sun, from this perspective, would shine as a white star with an apparent magnitude of 0.5, similar in brightness to Betelgeuse as seen from Earth. Positioned at the antipodal point of a Centauri AB's current coordinates, the Sun would outshine all other stars in the constellation Cassiopeia, situated east of Epsilon Cassiopeia E. Notable changes in the celestial arrangement would occur, with Sirius still reigning as the brightest star in close proximity to Betelgeuse, and Procyon outshining Pollux and Gemini, due to the altered distances within the new cosmic landscape. In potential planetary systems orbiting a Centauri A or B, the secondary star would appear as a brilliant celestial body. For instance, a planet akin to Earth located at 1.25 astronomical units from A Cen A would experience sunlight similar to that of our Sun, while a Cen B would appear significantly dimmer, yet still remarkably brighter than the full moon. Similarly, a planet at 0.71 astronomical units from a Cen B would receive sun-like illumination from its primary, with a Cen A shining dimmer in comparison, but still outshining the moon. The neighboring Proxima Centauri would be perceived as a faint star in the vicinity, distinct from its more luminous counterparts. Alpha Centauri stands as a prime candidate for future crewed or robotic interstellar expeditions. Although covering the immense distance between the Sun and Alpha Centauri using present spacecraft technology would span millennia, the development of advanced propulsion methods like nuclear pulse propulsion or laser light sail technology could potentially reduce the travel time to a mere 2 decades, as envisioned in the Breakthrough Starshot initiative. NASA has proposed a mission concept to reach Alpha Centauri in 2069, coinciding with the centennial anniversary of the Apollo 11 lunar landing, utilizing propulsion systems capable of achieving velocities up to 10% of the speed of light. Throughout history, Alpha Centauri has held significance in various cultures, including Polynesian star navigation, Ngurindjeri mythology in Australia, and Incan astronomical interpretations. The star system has been revered and identified in diverse cultural contexts, such as the Sagan Planet Walk in Ithaca, New York, and as part of the Southgate asterism in Chinese astronomical traditions.